So here is the video notes for week 10 exam on Thursday, what was that, November 14th. So two things that are needed to be known about a chemical reaction is a new product is always formed and mass cannot be created nor destroyed. So the law of conservation of mass, that's why we need to balance it. So you know a chemical reaction is true if the products are different, meaning the atoms are in a different atoms are rearranged differently. If you look on the right side and on the left side, the atoms are not like they are, and that does not include a state of matter. For example, this top reaction, this top combustion reaction, is a chemical reaction, and it's balanced because mass can be created nor destroyed. Hence, if we took the molar mass of both sides, it's going to be the same. But if I just took H2O and I put it, and there's gas, let's say you have a humid basement, put a dehumidifier up and you turn it into a liquid. Here, that is not a chemical reaction because the atoms are not rearranged on both sides. So we're going to look at oxidation and reduction. That is simply something's becoming more positive, something's becoming more negative. And that's because of a transfer of electrons. There's nothing from this slide that I want you to know. That is in Chem 2. And that's true also with this slide. Way to remember what is oxidation, what is reduction. And this is just an introduction. Before we get into it is Leo, loss of electrons. It says GER. So I write Leo positive, GER negative. So if you lose electrons, you become positive, and that's oxidation. And if you gain electrons, you become negative, and that's reduction. Just like it says down here. So here we have copper going from 2 plus, magnesium 0, copper 0, magnesium 2 plus. Something's becoming more positive and something's becoming more negative. You'll often find if you do outside research, or I think even in ALEKS, that they use something called oil rig. And if you want to use that, that's fine. So there are some rules when it comes to oxidation and reduction numbers. Now, oxygen, the most important two is oxygen is -2, hydrogen is +1. But if they're alone, it's 0. So O2, H2 are both 0, but all elements alone are 0. So if I wrote Li, Au, Ag, helium, I mean, you won't see noble gases, so I guess magnesium, all those are 0 if they're alone. Then group 1 elements, if needed, are always +1. Group 17 elements, if needed, are always -1. In polyatomics, you'll need a breakdown, and we'll do examples of all of these. But oxygen -2, hydrogen +1. Then group 1 elements, so those are lithium, sodium, potassium are +1. And the group 17 elements are the halogens. Remember, group 18 elements are the noble gases, so it's 1 over. So let's just do some examples here. Chlorine is a group 17 element. So if we have CuCl2, chlorine is a -1. We have 2 of them, so that makes it a -2. So copper has to be a +2. Then we have oxygen's always a -2. Chlorine's a -1. One rule I should have said earlier is if an atom is alone or an ion is alone, the charge of that ion is the charge that is on the ion itself. So chlorine's a -1. So for example, Mg2 plus would be the oxidation number would be +2. And chlorine is diatomic, it's alone, so it's 0. I'm going to give you some examples of some tougher ones that we did in practice, but aren't necessarily on the notes here. PO43 minus, what is the oxidation number of oxygen? That's always -2. So that makes that a total of a -8 because we have 4 oxygen. The overall charge is a -3. So we have to determine what phosphorus is. And phosphorus in this situation is a +5. So if we have Cr2O72 minus, well, that one's tough. Oxygen is a -2. Makes this a -14 because we have 7 of them. It has to be a -2 overall. So that means the Cr2 would have to be a +12, but there's 2 Cr2s, so that makes Cr a +6. And I'm just going to do the math here and sort of prove that that adds up to a -2. So if Cr is a +6, and there's 2 of them, that's 12. And then if oxygen is a -7, no, -2, and there's 7 of them, that's a -14. It adds up to -2. We get the same charge. Here it's sort of just the same thing. I'll do one example on the next page. An element is alone, it's 0. If bromine is a -1 charge because it's in group 17, that means iron is a +3. On the product side, bromine is a -1, so aluminum is a +3, then iron's alone. So LEO, loss of electrons, positive, gain of electrons, negative. So what's becoming more positive? We have the aluminum. So the aluminum is the reactant that is becoming more positive. And then what is becoming more negative? It is the iron bromide. Because the -3 is going to, for iron is going to 0. Keep in mind that bromine stays the same, but we're writing the entire reactant. So I am going to give these to you unbalanced. So I'm going to have you balance them. I'm crossing off some stuff here. So essentially it will look like this. You can go back and look at the ALKs and just realize that they're just not going to be balanced. And then you're going to have to solve them. However, whenever you see something outside the parentheses, that nitrate, that NO3, we're going to have a 2 there. And then we have to go back to the other side. We have a 2 there. So that is balanced. And once it's balanced, now that coefficient has nothing to do with the oxidation number. I could write a 1 in these as well, I guess. The front number, the coefficient, has nothing to do with the oxidation number. Nitrate is from your polyatomic sheet. So I'll give those to you this week to practice so you can see what you're looking at. So nitrate's a polyatomic, that's +1, silver's, if nitrate's -1, silver's a +1. If it's alone, it's 0. And then copper's a +2 here. All right, that makes sense because we have a 2. All right, so then what is becoming more positive? We see the copper is going from 0 to +2, and then the silver is going from a +1 to a 0. This one is already balanced, and I bet the oxidation stuff is decently easy after some practice. Now, let's just run through some oxidation numbers real quick. Potassium group 1 +1, iodine group 17 -1. We're not paying attention to those front numbers. Chlorine is group 17 -1. That means copper is a +2. And then on the right side, copper is iodine's -1. That means copper is a +1. Because all those charges are canceling each other out. I2 is a 0. Cl -1, K +1. I don't see too many hard ones on here. Here, H is always a +1. S is going to be a -2 because there's two H's and it has to cancel out. Sodium is going to be a +1. OH is polyatomic, so that's -1. Sodium is a +1 always. Sulfur, that's going to be -2. Hydrogen is always a +1. Oxygen is always a -2. And then if we look at the red one, sulfur on the left is -2, sulfur on the right is -2. So nothing, it's neither being oxidized nor reduced. The next one there, since oxygen is a -2, carbon has to be a +2. Oxygen is a -2, carbon has to be a +4 because we have two oxygens. So they're getting more positive. So loss of electrons, positive. So it is being oxidized. Do one more here. Chlorine there. We're forgetting about the coefficient in front is a -1. I mean, we don't have to do all of them. Chlorine there is just a 0. Oxygen would be, or hydrogen would be a 0 because it's alone. Oxygen is a -2, hydrogen is a +1. That makes sense because that adds up to a -1, and hydroxide is a -1. And then oxygen is -2, hydrogen is a +1. And that's always true, but that also makes sense because H2O is a neutral compound and we have two hydrogens and one oxygen, and that adds up to 0. The combustion reaction, I'm going to say that till the end. We're going through it also this week, week 11, so I won't waste time on the video right now, but you will have to balance these. However, I'm going to ask it in a sense more like I do later, where you have to write the products yourself. You can balance these, you can practice balance these equations on ALEKS, but the goal is to get the same amount of hydrogens, oxygens, nitrogens, and everything on the same side, the same amount. And it looks like nitrogens and hydrogens are balanced, or nitrogens and carbons are balanced. So then we're going to go with hydrogens. We got a 3 and a 4, so we have 7 total. And so if you're struggling with these, balance or practice them with your homework. So to balance hydrogens here, I could put a 3 there, and that's going to balance hydrogens. And lastly, I can balance oxygens. Now, if we look at these right now, nitrogen is 1, hydrogen is 7, carbon is 1, oxygen is 2. On the product side, nitrogen is 1, hydrogen is 7, carbon is 1, oxygen is 3. So let's say you have to balance this. And I mean, you just want to get it over with and you balance it, and you just need to balance it. So keep in mind you can use a fraction, and that seems to be the easiest way to do it. Now, if you don't want to do that, the other thing to do is always just put a 2 in front of usually the first one or the most complicated one, and that's going to work in this instant as well. But if you put a 1.5 here, oxygen is now going to be 3. Or you can just take that number and put it above whatever this number is, 3/2. And this is balanced. However, you can't have a fraction, so you're going to just multiply everything by 2 right now. So the answer is going to be NH3 plus 3O2 plus 2CH4 forms 2HCN and 6H2O. So, and then you can add them up. Make sure nitrogen we got 2, hydrogen we got 6 plus 8, and I added up these hydrogens and these hydrogens. That 2 distributes in. So like a 2NH3 is simply saying NH3 plus NH3. That's N2H6. And so hydrogens have 14, oxygens have 6, carbons have 2. And this is messy, but no, so on the right side, hydrogens have 14, 2, and then 12, carbons 2, nitrogens 2. And keep in mind the ones that I'm going to get are from your homework. Oxygen 6. The rest of this will be the last one to do. The rest of them I put in week 11. So the last part of week 10 I put in week 11 with a couple more things. But here, Si4H10 plus O2 forms SiO2 plus H2O. So I want to balance silicones first. We got 4. Then balance hydrogen. We have 5. And so everything's balanced at this point other than oxygens. So oxygens are last. So we got 8 plus 5. 8 plus 5 because that 4 distributes in. And that is 13. So we can put a 6.5 there. And multiply everything by 2. That ends up being a 2Si4H10 plus 13O2 forms 8SiO2 plus 10 H2O. Now if you're ever in trouble, just put a 2 in front of that complicated one. The first one usually, but not always, but we see a 2 there. And the most complicated one, even if you look at the toughest ones to balance, there's rarely, if ever, a 2 more higher than a 2 in front of that. So that's it for week 10, because the rest of week 10 is in week 11.